Okay, so we have this playlist that is been curated on leetcode. Actually, it is all about dynamic programming. So what I found in interviews very often is they used to ask dynamic programming problems when it comes about great companies like big giants Fang and Mang and all. So they used to ask these dynamic programming questions a lot. And if you are some beginner who are not used to it, and if you want to start it, then you can go through this playlist. So what I'll be doing is I'll be solving all the problems that is there in the dynamic programming list, and then I'll be providing a solution for that. There are some 10 different types of dynamic programming problems. I'll be solving everything from the scratch. So today's problem is climbing stairs. I'll be explaining you this problem. So this problem is all about climbing the stairs. So there you will have a climbing staircase. It takes n steps to reach on the top. So there are n steps, okay, in the stair, and you have to reach on the top. And there are two constraints. If you are at any level, at any stage, you can either take one step or you can take two steps, okay. Neither lesser than one, nor you can take more than two. It means you can't go down and you can't go above than two stairs at a time, okay. So this is the actual scenario, okay. So they are asking me, tell me all possible ways, how many ways are there in which you can climb these stairs. So if I have to go through an example, so I actually created this so to make you understand, okay. So if we have n equal to 3, so if you start from here, you can go at 1, then you can directly go at 3. So it will be one way. Then from here, if you go at 1, then directly you can go to 2, and then you can go to 3. So it is the second way. And the third way is if you are at here, and then you can go to 2, and then you can take one step more to 3. So there are three ways. So for n equal to 3, then we will get three ways. Say likewise, if you have suppose 2, okay, this we have, okay, and you are here, so directly either you can climb here or you can do this here, then here, okay. So there, this is path 1 and this is path 2. So you have to tell all possible ways, okay. So this, and suppose you have only one like this, so you have only one way. Suppose n equal to 0, either actually n can't be 0, but I'm telling you n equal to 0 means you can't go down, you can't go back. So even this case will not even come, okay, because they are given this constraint, this n starting from 1, okay. So there are actually three ways to solve any dynamic programming problem. You can either do it recursively, or you can do it iteratively, or you can memorize that recursive solution. So I'll be solving all the ways how you can solve it, okay. So if suppose you have this n, and suppose I'm calling this function return this recursive, okay, recursive n, okay. So this will come to here, okay. So if our n equal to 1, so this means if your n equal to 1, then you will take only one step to go to on the top, okay. And other ways, if n equal to 2, if n equal to 2, then I've told you, if you are here, then there are two ways, okay. So for these two cases, if n is okay, so if n is less than or equal to 2, then in that case you will return n, because for n equal to 1 it will return 1, for n equal to 2 it will return 2. I've told you that is a base case actually. So I've told you how it is working, okay. So after that, what you can do is, suppose okay, suppose you are somewhere here, okay. So from here you can have lot of like possibilities, you can how you can go on top. So we will try all the possibilities, and you will try to add all the solutions, okay. So that way we will be doing here, okay. So at every step you can take only two step ahead. So you will do this into equal to wherever you are recursive n minus 1. So basically you are taking step 1, okay. You are taking one step up, okay. And the second thing is int b is equal to recursive n minus 2. In that case you will be taking two steps, okay, and it will be like this, taking two step up, okay. And then you have to add these two, whatever possibilities are there, whatever combinations you can try out, only two combinations are there. Then you have to, like, suppose from taking only one step you get suppose three possible ways. So here, okay, so you have 3, okay. So you are here, okay, So you will take step 1 and you will take step 2. So you will, whatever from here, whatever answer you will get, you will add, like you will add like A, and you will add B. Okay, we don't know like how many types of different paths will be stored from here, then from here, we don't know, but from here we will have these many options. We will add all possible answers by taking one, and we will add all possible answers by taking 2 steps. So we will do this. Okay, so we'll add these 2 and then we will return. What we'll do, return A plus B actually. Okay, and this is our solution. Okay, if I'm going to run it, so it will be like, okay, so actually I actually created one function that I'm not using. Okay, so you will get your answer. Okay, but the actual problem with this is it is not actually a right way, because if you go this way, no, so there will be a lot of complexity. So suppose you have n equal to, suppose 5. Okay, so what you will do in every each step is, for n equal, you will take 2 steps here. Okay, you will do n equal to 4 here, and then you will do n equal to 3 here, 3 here, and again from 3 you will do this 2 here, and you will do 1 here. Okay, again you will do this 0 here, and you will do this 1 here. Again from here you will do this only 0 you can do. Okay, you can't go -1. Again you can go only to 0. So if you can easily see, no, you can easily see there is a formation of tree. At every step you are having 2 options. So for every possible, suppose n equal to 10, so for 10 times you will have 2 options. Always you will have 2 options. So what will be the complexity? The complexity will be 2 to the power n, and this is actually exponential complexity, and you will not be able to submit your problem, actually your answer, by this complexity. So you have to memorize it. What is memorization doing here? So suppose I'm taking a test, I'm taking a case here. Okay, so if n equal to 4 here, then here it will be n equal to 3, and here will be n equal to 2. So if you see clearly, you have already calculated answer for 3, and for that answer you can use it here. You can use this answer here actually. Okay, so this is the actual crux behind that memorization. If you are calculating answer for n equal to 3, then why are you again going to calculate this answer? Okay, this tree answer, you don't need to click to do that. So what you will do is you will store the answer of 3, and that answer you will use further later on. So this is all about DP, this is all about dynamic programming. You will be doing that. Okay, so what we will be doing is we will be doing a memoization. So everything will be the every code will be same. The only thing will be changing is we will take one array actually, or you can say, okay, we will take one array of size and or something like that. So suppose we will take one map. I'm taking one map. Okay, map of int comma int m. Okay, this is for, you can say, it is memoization map. Okay, memoization map. Okay, I'm saying only memo map. Okay, this is memoization map. So what I will doing is we will do these same thing. We will do same thing, no change. Okay, no change, same thing, but we will try to store our answer. That's it. Whatever we are calculated, we will try to store that. Okay, so suppose we have n something, and so we will just check if this n for answer for this n we have already calculated, then we will not calculate further for this n. Okay, so if n m of n is there. Okay, m of n. Okay, m dot count n. Actually it's a way to check if a particular element is there in the map. If it exists, then you will return this, return m of n, and if it not exists, then you will calculate these 2 answers, and while returning your answer you will store that m of n equal to this, for that you can later on you can use it. Okay, so now this was the first way. Okay, let me show you this. Okay, so this was your first recursive way, and this is your iterative way. Okay, so I gonna call now this memo function. Okay, return memo. Okay, memo means memoization with n. Okay, and I'll comment it out and I'll check whether it is working or not. Then we will have some DP solution as well, so I'll give you logic how you gonna do that. Okay, return have 2n. Sorry about that, it's only 1 in there. Okay, so this was the actual solution that we was looking for.